Hello everyone and welcome to WEkEO Copernicus DS Service Training number 1 for universities. My name is Daria, I'm from Novelties, and today I'm here to do a short presentation on how to download and use WEkEO Copernicus service products and specifically use them in QGIS software. To do so, we will focus on study of a 2022 European heatwave, and the heatwave itself is a period of excessively hot weather measured relative to the usual climate in the area and relative to normal temperatures for the season. And last year, 2022, during the summer, several persistent heat waves affected the Europe, causing evacuations and heat-related deaths. The highest temperature was recorded in Portugal. It was around 47 degrees Celsius, and it was on 14th of July. Here on the right, in the picture on the right, you can see a representation of extreme maximum temperature in Celsius, which occurred during 5 days in July 2022. And to use WEkEO Copernicus service products in QGIS software to study such phenomena, we first need, of course, to download them. And to do so, we can use two different ways, two different methods. And first, what we should do is we should go to WEkEO website, which is WEkEO. And here you can see a lot of information. You can scroll through the site, browse through the site, and see a lot of examples, a lot of information, pictures, data, and so on. What we're going to do is we're going to the tab Data. And here we see that data viewer, a very nice interactive way to see different data sets and also to play with them a bit, to represent several of them at the same time, to layer them, to find information. For example, here we see right now is a seawater velocity. We can uncheck the layer. Here we have some information. You can find basically any information about this data set. You can subset any other variables that are available in this exact product. And also you can, of course, download this product, this variable, um, specifically from here, from Data Viewer. To do so, you of course need to sign in. Here you will need to sign in, and if you don't have your account, of course you need to register first. To download here, you have different options. The options are not the same for all the products. They might vary. So usually it can be a bounding box. So for you to choose a different region, which you can set here, like this, for example. Copy it here. Or you can put it yourself if you know some coordinates. You usually can choose start and end date, or choose some months or days and years. You choose variables, choose the output format if it's available. So yeah, it's for each product, the subsetting for downloading could be different. And then when you're done with your all your settings, your options, you just request data, and after it goes here to jobs, and it's in status of processing and then completed, or could be some error, of course, but then you just open log and read what has failed. But also another way of downloading the data, it's not only from data viewer, it can be also done through the code, through the Python code, if you are um, more comfortable with that. To do so, you can follow instructions which are also given on the WEkEO website. You can go to the main page, you can click on this button, this is a help center, and basically the first suggested article for help is how to download WEkEO data. You can open it, you can see it right here, or you can scroll down and open it in the help center. So here you basically can see how to download data from the data viewer, as I just said, so more precisely step by step, or download data via harmonized data access, which is basically a Python code. And to do this, you just you download an example notebook in Jupyter notebook format, and opening it, you have basically cell by cell execution in which you can by executing it, you can download all the information, all the data you need. Since it's a brief presentation of how to work with WEkEO data, WEkEO products, I'm not going to stop on downloading a lot, especially knowing that there's quite good and thorough instructions. What we're going to do is we're going to switch specifically back to our QGIS software. And also here, I'm not going to do step by step um, all the procedure of how to create, how to open, and so on. If you want to know more precisely how to do each of the steps, you can first, of course, open a PDF file, a PDF version of this tutorial, which will be provided to you, and follow the tutorial in PDF because it's more precise. Or you also can check the videos for advanced tutorials for other trainings in QGIS software. So here I'm not gonna say a lot of details. I'm gonna just briefly um, go through different exercises has been done to use WEkEO software. And firstly, of course, we did what we did is we put a map of a world on our background for better representation. How to do this? You can add it through Layer tab, or for more details, you can go to PDF file. In to map the variables, we use the netcdf file management. This is a plugin developed by Novelties. And here in this for WEkEO, for this tutorial, for tutorial on WEkEO, what we use the Era 5 land data. So here we use a 2 meters temperature, so the temperature on 2 meters level. And originally it is given in kelvins, but this data has been a bit improved with Python code, and another variable has been added to the dataset, which is basically the same temperature on 2 meters but in Celsius. And also the second program that has been used is also Era 5, but it was meteorological data from Era 5, and the variable that was chosen is relative humidity on 2 meters. So these two variables have been these two files have been loaded, the variables has been plotted, and now let's see what was done in exercise number 4.1. So in the first hour exercise. Um, so here, as we study heat wave, we will focus on the air temperature, of course, to see how it evolved. And we will see where's the temperature is the maximum, where is it the most dangerous for humans. And also we will look at the air humidity because dangerous temperature, risk temperature of air is assumed to be in the combination of air temperature and relative humidity in air. So for the first part of the first exercise, what has been done is the temperature, 2 meters temperature in Celsius has been mapped. So I tick a box. Here, yes, you can see that I opened already made project. I'm not gonna do everything from the scratch. So if you again want to follow from the beginning, you can follow tutorial in PDF. So here I just tick in our layers. Here you can see part of Europe, not the whole Europe. The product was downloaded only on this extent. You can, of course, when you go through this tutorial, you can use data that we already downloaded, or you can go and subset your data yourself and choose bigger or smaller region as you wish. So here, this is a representation of a temperature in Celsius, and you see that the blue corresponds uh, to low temperature around 3 degrees, and the red corresponds to 42. So like this, we see quite normal, usual summer, quite hot, especially in the south of Europe. But if we go through our several dates, yes, actually time frames here loaded every 10 days, starting from 1st of June and ending on 30th of August. So if we go through them, we see how the temperature, air temperature intensifies. And here, for example, on 20th of July, we see several regions of Europe affected by extremely high temperature. You can go and scroll through all of them. Yes. So there are several time frames, but for our further study, we will focus only on one, and we decided to choose 20th of July since we can see clearly high temperatures and high temperatures which are affecting several regions of Europe. You are, as usual, as always, you of course um, free to choose any other time frame you want. So as we chose it, let's only tick it and untick it now. So what we're gonna do is we want to know we want to know air temperature in different zones of Europe. So we want to know zonal statistics for Europe. To do so, we want first to separate our map, uh, our just geographical map to political map. So we want to add some borders. To do so, we tick this layer, and this layer is actually being downloaded from a website. You can see all the information about this layer in a PDF file. And to add new layer, especially external existing layer, what we do is we click on layer, we add layer, add a vector layer. I mean, now it's line, so it's a vector layer. It could be also a raster layer. And here you need to browse through the here, for example, I have all the data. Yes, I have world countries boundaries. And here I choose the shapefile. I'm not going to import it now. It's just a brief reminding for you. So when I do all this procedure, I now have borders over whole world. And now what I want to do is turn these lines to polygons because zonal statistics of the temperature we want to know, they are available only for polygon layers. So to do so, we go to our processing toolbox tab here. If you don't have it on your right, then you just open a new project. In QGIS, you go to processing in various toolbox. Now, for example, I untick it, and now, yes, it's here. So what we're gonna do, we're gonna search for polygonize, and here we see different types of polygonizing. We need the vector geometry, this one, polygonize. When you double click on it, you can choose input layer, which is only the lines. So if you see it here, you see that this algorithm takes a lines layer and creates a polygon layer from it. So you put our imported country borders, and you can save or not save. Again, it's up to you. And you run and close it. So we already did it. So we have, as a result, this. This is our world countries in polygons. Now you can see them in green. But as we are focusing only on European heatwave, we don't need all of them. So what we're gonna do is we're gonna subset our world countries to European countries, or how it's actually here is only several of European countries. So to do this, we need to choose them, and what we're gonna do, we're gonna choose them manually by using the tool of selecting features. For this, we need to highlight our our world countries layer, and we go to here, select features by area or single click. Here you can choose by polygon, by freehand, by radius, whatever you want. We just put select features, and like this, you can choose any area, and if you want several areas, you of course hold Control and choose several of them, for example, right? If you want to verify which exact countries are already in our region of study, you can tick our, yes, it's not very helpful actually, to tick our temperature layer on and turn off world countries to see, like, we see the border, turn on, okay, these countries are still in, I think, yes. And like this, you add them more, and after they all chosen, what you can do is you now go to world countries layer, you right click and you go to export and save selected features as, because we want to export only specific features because we chose them. So here you should use shapefile as a format. Set the name. Here it will be European countries, and you should make sure that this one box is ticked. Save only selected features, and also add saved file to map this one. I'm not gonna do it because I've already done it. I can, oh, wait, I can unselect them all by clicking like this. Good. And what I've done already is I created a new shapefile with some countries. Of course, I did not specifically added um, some of them, some small islands and so on, but that's not very important. It's just to see some representation. You can, of course, add less of the regions, less of the countries. So now we have our European countries, and what we want to do is, how I said before, to do a calculation of zonal statistics. And for this, you go to Processing Toolbox, you go to Raster Analysis, you open zonal statistics, and here you need to choose several layers. And tick, tick, tick. So since you want to zone statistics on several regions on a specific date, and the date was 20th of July, we choose raster layer as 20th of July. Here we choose European countries only. Here you can change your column prefix if you would like to, but it's not really important. And here, statistic to calculate, you click here and you see different ways, different options. What we're gonna do, we're gonna choose mean, minimum and maximum. So mean and max. You click on OK, you have the option selected, you run and close. As I said, I'm not gonna do it because I already done it. And basically what it does, it creates another polygon layer, basically the same as you had before, but now it has a different attribute table. So when we open it, we can see the ID of our chosen country, and we see mean, minimal, and maximum values of the temperatures there. To see what is this ID, what is this country, because it's not really clear, you can just right-click, flash feature, and you see, flash feature, and like this. So if you, for comparison, open just EU countries, which we created, you just have only ID. Another feature of a QGIS software which we want you to show to you is how to highlight some zone, some polygon under a certain condition. And for this, these polygons, they only contain, as we saw, mean, minimal, and maximum value. So what we're going to do now is we need to convert this raster layer to a vector layer, so basically polygonize it. And to do so, you can click on a raster, conversion, polygonize. Here you choose input layer. This is our input layer. You put name a field to create. So here it was temperature, for example, or whatever. You can save or not save. And as a result, we will get this picture. I will unload it, but actually not this one. Let me do something. So we'll have this. So all the zone, all the raster layer you had before, like this, has been vectorized. It was being vectorized land and of course the C2 because this when it vectorizes also the polygons that are like adjoined to all the polygons. So it will create the just a big one big polygon for water, for seas and ocean. So now we have this, and what we want to do is we want to filter, as you might see, what I've already done. We want to filter, for example, we go right click, filter, and here you can choose a field. It's a temperature. I already have my condition. Is the temperature is more than 37 degrees Celsius. This temperature has been chosen because to the health concern after 37 degrees with of course combination with relative air humidity, this temperature might be too dangerous for normal existence of human beings. So we decided to choose this one. You put it and you can put test. And yes, it will take some time, I guess. So after it's finished, it showed that it has only 119 rows. So here you see that our area changed. Now we have only some green polygons, not the whole area. We click on OK. We can a bit zoom. Uh, so we see it means that these areas exactly have temperature more than 37 degrees Celsius. And before we move to some other analysis, what we want to perform is we're going to fix the geometry because very often when you polygonize so you convert from raster layer to vector layer, some of some of the geometry, some of the polygons, they become invalid. So to avoid this, because if it's you have some invalid geometries, you cannot perform a lot of spatial calculations. So to do so, you need to first fix geometries. And fix geometries, you can just search for that. Here, you can choose this vectorized zone and some output layer. So we already did it. So we have this, which is basically exactly the same, polygons, but now all the errors that occurred during the conversion between raster and vector layer, they've been solved. So now what we want to do after we fix the geometries, we want to compute the area under this threshold we selected under 37 degrees, but more right is to say more correct to say that more than 37 degrees. But to do so, we first need to convert um, our filtered zone to one polygon, because if you zoom, you can see that actually this polygon consists of several small polygons. So to do so, you go to Vector Geoprocessing Tool, and you put on Dissolve. You choose your zone, it was this one. You choose the place to save, and now we would have this instead. So now if you look closer, you will see that all the polygons have been inside, they've been dissolved. So now we have, let's say, just we have less of polygons, but like bigger, let's assume. So here in Dissolve, you can open attribute table, and you can see the its ID and the temperature, the overall temperature. And see you here, you already can see the area in kilometers. So this is basically what we want to know. But initially, you won't have it in your attribute table if you open it. It's here because I've already done it. And to add this area calculation of area in kilometers, you choose your dissolved zone. You go to editing mode with pencil. So now you can see what pencil appears. So it means that this layer is under editing mode right now. You right click, go to properties, and in the properties you go to fields. Fields. It's here. Here you can see that I have this field already added, but to add it, you first need to click, like to add it first place, field calculator. And here you have a field calculator in which you can basically add any column to your attribute table. So you create a new field. Here you can choose the format of it, for example, real. You can choose a field length, then precision, put the name, for example, area. And here you put expression. We put an expression of, just a second, it was this expression, like this. And here you already can see output preview that gives you the area in kilometers. You also can play and look what this all these little little hints give you of what you can actually calculate. So when you click on OK, you can apply, OK, cancel, and like this, you also need to exit editing mode, and it will ask you to save or not. You of course save, and then again you open attribute table and you see your new area calculated in kilometers. So that was all for the first exercise. And when we were working with air temperature and looking at its evolution and performing several tasks. So now what we're gonna do, we move to another one. We can untick this one and open this one and tick it. And for this one, we're gonna work with relative air humidity. So as I said before, and also in the tutorial, you can see some more information about the correlation between relative air humidity and air temperature, how together they work, and how it influences, how it impacts the human's health. So what we're going to do is, now here you see our relative humidity. I put it, and yes, this relative humidity is actually um, for the whole world. It's been also imported by the same tool, by the same plugin. You choose it, there's only one variable, you right click, add layers, and there's actually only one date because we imported only one date. It's the same date, it's the 20th of July, which we used for the first exercise, just to match them. You could put add and close, and you will have it here. So this layer was just imported as it is. You can also change the style. You go to properties, and actually the previous in the previous exercise with air temperature, the style also has been changed. It also has been tuned, and it's up to you how you tune it, how you change it, which colors you choose, and so on. So what we are doing here is we need to choose equal interval. We choose 5 classes, 1 to 100, to 0 to 100, good. And we leave the color ramp like this. So it means that blue corresponds to more humid places, to where relative air humidity is high, and red corresponds to more dry places with low relative air humidity. We choose it, we click apply, we click OK, and now we have a picture which is basically changed. We zoom closer to our region. So now, as I said, we have for entire world, and we need only Europe because that's what we are working on the European heatwave. And to do this, we can use such a tool as a clip layer by mask. And this is a raster layer. So to do this, we go to raster tab, to extraction, and clip raster by mask layer. Here we, of course, as input layer, we select our relative humidity, and as a mask layer, we can choose our European countries, our world countries, which will not give us basically anything because it's the same, the extents are the same. Or what we can do is to choose our filtered zone to have air humidity only on the places which we already studied to have air temperature higher than 37 degrees Celsius. So we do this. We need to put the source CRS, and which is very important when you clip raster by mask layer, you want to use this tool, is to tick this box, keep resolution of input raster layer. You can set the name, you can run and close. So this is this exactly resulting layer. I will untick this. So now you can see that this is exactly the same places, the same areas that we already studied in exercise number 1. I will open it up. Let me untick this. So if you up, you can see that it's exactly the same exactly the same zones. So let's untick them. So now we have our clipped area here, and you also can do what you can do is to copy a style of this relative humidity layer. Styles, copy style, and you can right click and paste it here to match it. But as you see, it's basically basically the same. So now we want to see the distribution of our relative air humidity values to like relative to latitude and longitude of our locations, our positions. To do so, we can use a 3D scatter plot, and QGIS has a built-in tool for plots and histograms. And although this tool is not entirely convenient for plotting purposes, it lacks plot tuning options, and it's much easier and faster to do the same plots, basically using the same files and variables, for example, in Python. But we still find it useful to show briefly this feature so you know about its existence. But first, what we want to do, as we want to do a 3D scatter plot, 3D scatter plot should be done through from points layer, and we don't have points layer. So what we want to do is we want to convert our raster pixels to points. And to do this, you can see it in processing toolbox in vector creation, raster pixels to points. Exactly this one. You choose your clipped area. You choose a value, you can change its name, you can run it, and you can close, and then you will have this. As a result, you will see that our areas, our zones is now covered with points, and if you zoom, you can really see that each pixel, this is a pixel, right, is replaced now with 1 point. So that's how it looks like. What we want to do, so now if you click here on Open Attribute Table, you will see the temperature. So each point has its temperature, which is corresponding to the pixel it was before conversion. So now we have temperature, and what we want to know now is longitude and latitude of the points, so to be able to do scatter plot. So for this, we go to toolbox vector table. Vector table, you of course can just put it in a search bar and search for it. And we need to add X, Y fields to layer. Here we have here you can choose only points layers. We have clipped area points. You choose coordinate system. It should be yes exactly the same. You put your new name. You put a prefix if you need. You run and close, and as a result, you will get basically the same points on the same places, just in another layer. And now it has more columns in open in attribute table. It has X and Y. You can see that X is our longitude, so it's this axis, and Y is our latitude, is this direction, this X. So now we have it, and we can do finally our scatter plot. To do this, we go to Toolbox again, and we see the specific tab. It's called Plots. Oh, it actually does not have it here. Okay, so apparently it does not have it here because this version of QGIS is older than our version we used. This is, I believe, 3.10, and to create this one we used 3.20. So this also can depend on your QGIS version. So it's better to use the more or less new version of QGIS. It's actually mentioned in a tutorial, in a PDF version of this tutorial, because also the plugin for NetCDF files, this one plugin, may not work correctly with older versions of QGIS. So yeah, But this is not a problem because I think it actually should be somewhere here. Just oh, graphics. Okay, so actually, if your version of QGIS is a bit older, the tab in toolbox which called plots for newer versions can be called graphics. So it's actually graphics. What we need is a vector layer scatterplot 3D. You click on it, and now you can choose your input layer. We have our XY layer. So you actually can see that you also can do the plots from any vector layer, not raster. You can see that there is no raster layers, there are only vectors, so polygons, lines, and points. But on polygons, we don't really have any values, any information inside it. So we choose this one. And now we have X, Y, and Z attribute. And you can play with this exactly, but we decided that the best representation would be if you choose temperature as an X attribute, X as an Y attribute, and Y as Z attribute. Yes, a bit, a bit confusing, but yes. So you run and you close it, and then you run it. Actually, let's run it like this. And we will see because it will give you an output as an HTML result. Yes, here you close and you see this results viewer tab which opened. You can see this histogram. You also can save it and it will also be saved as a HTML link to the directory you saved it to. So we click on it and it should open. Yes, it opens it. And now you see the graph, which is interactive, and but how can, as I said before, it's not very representative. There's no that much tuning. You can of course zoom in, zoom out. You can rotate. You can check basically each point coordinates. Like this point has these coordinates as YZ. This is the longitude and latitude. And first one, X, is the temperature. You can also see it here. So you can rotate, you can zoom, you can have a screenshot, I think, download what as a PNG, you can, yes, do all the stuff, do all the ways of rotation. And here you can see different, you can see the correlation between temperature that we studied in the first exercise and the relative air humidity, which we studied in this exercise. So yes, if you will look at this HTML plot, scatter plot, and if you go back and you look at the, uh, if you, yes, here, where is no, it's not here. Mhm. Yeah, if you go through some of the values here, you can maybe see the correlation between relative air humidity and air temperature. So yes, let me open it up. No, it was here. Yes. Again, you can also play with the plot, try to maybe plot it in different, choose your axis differently. But yes, there is such an option as a plotting option. And as you can see, there's also different plots for both raster and vector layers. It could be histogram, it could be box and bar plot and everything, and they all saved as HTML link. So that was all for the second exercise, and this actually was all for the whole training. So here we very briefly, without going to details, looked on how to download the WEkEO Copernicus service products from the site through Python applications or through data viewer online. And we used them to study the European 2022 heatwave. We studied air temperature, how it evolved during the summer of 2022. We also looked at the air humidity, relative air humidity, looked at correlation between them. And what we learned to do is we saw how to export our borders, so some external layer how to convert the lines, so it was line layer to polygon layer, how to choose several polygons from the bigger set of polygons. We learned how to do a zonal statistics, how to calculate zonal statistics on the polygons. We learned how to vectorize and filter our raster layer. Also, we also saw how to fix the geometries, and also to use dissolve function to create to merge polygons, several polygons to one polygon in order to compute the area covered by this polygon. And for the second exercise, what we saw is how to clip a specific area, clip specific area on specific condition, and then how to convert this. So it was raster layer, how to convert this raster layer to points, and how to add some geometries to these points, like coordinates of these points. And from it, we learned how to use this data to do a small plot. So that was all. I hope it wasn't too fast and too hectic. I hope you learned something new, but you enjoyed it. And yeah, you can always play more with the same data on the same region or the same data with another region. You can download more products from the WEkEO Comparing Service website, and yes, you can play around with different regions and different other QGIS features. So yes, I hope you enjoyed it, and I wish you a very, very good day. Bye.